In this video, we're going to look at Curtius reaction, and this Curtius reaction technique is important when it comes to looking at carboxylic groups that are going to be undergoing a form of transformation that leads to the formation of our amine. And this is going to imply the process that is as follows. One is when you're giving a reagent that is given in the sense of R group with this carboxylic group, and this is known to be an acyl chloride, and this is going to be subjected to reagents, which is one is sodium azide compound, and this is done in the presence of water. This will lead to the formation of products 1, 2, and 3. Now the question I'm going to ask you is, what are the products that are formed? And second is, provide the mechanism for this particular reaction. So first is, we need to determine the mechanism, and by so doing we're going to arrive at the specific products that are formed during this particular reaction process. Now, looking at the mechanism behind this particular reaction, what we need to arrive is that yes, we need to be able to determine where our specific group, which is the acyl chloride, is going to be sensitive to an activation process, and this here is due to the presence of our azide. And our azide, when you draw the structure, we notice that we have the nitrogen double bonded with nitrogen here, and also double bonded with this nitrogen. Take note here that due to charges that are going to be present here, we have a negative charge right here, we have a positive charge right here, and our negative charge right here. Now take note that this here is due to the presence of two lone pairs that are present around this nitrogen and two lone pairs around this nitrogen. Therefore, any of this nitrogen that you see at both ends that are negative charged will be sensitive to the interaction with the carboxyl group, and so due to nucleophilic interaction, that leads here to this lone pair to interact with this carbon. Therefore, this double bond reforms, and this leads to the breaking of our carbon chloride bond. Therefore, this leads to a good living group, and our intermediate product is as follows. Now take note here that this lone pair that's around this nitrogen here is undergoing a donating factor. So the donating contributing factor leads to the bond to be formed here, therefore causing this bond that is our pi bond to form a lone pair on this nitrogen, and this is a resonance that is going to be established, that is a back and forth intermediate with this other structure that we have here. Take note that due to this back and forth resonance at this intermediate state, take note that this will result in a favorable result, which is the cleaving of this particular bond that will favor the release of a nitrogen gas. And so what happens is that this bond forms a lone pair with this nitrogen, and this leads us to the formation of, and take note that in here we have this release of nitrogen gas, and in here we have this product that is called a nitrine. What happens is that due to this nitrogen here, which has two lone pairs and one bonding pair, this tends to be really unstable. Therefore, what happens is that this R group is going to rearrange and form a bond with this nitrogen, whereby this lone pair forms a double bond with this carbon. Therefore, this will lead to the formation of this, which forms a carbon with double bond with oxygen. This carbon forms a double bond with nitrogen, and this forms a single bond with the R group. Now this here is known to be called the isocyanate, and this here will lead us to another reaction where in the presence of water comes in, and what happens is that the oxygen that is present in water particles will be able to form a bond due to the presence of its lone pair with carbon, and therefore this leads to the breaking of a pi bond to form a lone pair on this oxygen, and this leads to the formation of this. Now remember that since we have a positive charge and a negative charge, we know that while on one end we have our water to be present to deprotonate this hydrogen here, this will form a hydronium, where the hydronium would donate its proton to this particular oxygen. But this here is going to be at equilibrium between one end and the other end, where on one end we have this hydroxyl, two hydroxyls attached to this carbon, and we have a double bond with nitrogen and with that of our R group. And this here, in the presence of water again, when water is introduced, we're going to have the deprotonation of this particular or any of the OH that is here, and the deprotonation will lead to another equilibrium that is going to be established because of the formation of a double bond right here. And so what happens is that this process, which is called tautomerization, double bond between the carbon and nitrogen to pick up a hydrogen atom from an hydronium. And so what happens is that this picks up a proton, and this leads to the formation of this carbonic acid. Our next step is to look for how to be able to use water to rearrange a couple of bonds, and to do that all we have to do is introduce water. And what water does is that its oxygen picks up this particular hydrogen. The hydrogen-oxygen bond forms a lone pair on the oxygen, while remember we have a lone pair on this nitrogen, which is going to be picking up a proton from the hydronium that was formed during this particular process right here. And so what happens now is that we're going to have a equilibrium between this reactant here and the other intermediate here, but the left side is way more favorable than the right side. And what we have on the right side is, now this here leads to the final step, which involves the release of the gas, which is in this case carbon dioxide. And what happens is that due to the presence of a lone pair on the oxygen, this forms a double bond with the carbon, therefore causes this carbon-nitrogen bond to cleave to form a lone pair on the nitrogen, and this leads to the formation of two other products. One product to be aware of that is really important is the R group that is bonded to the nitrogen with two hydrogen atoms bonded to it, which is in this case a primary amine, while the other product here is the release of carbon dioxide that is produced during this rearrangement process. So I hope you found this really informative in terms of forming a primary amine and the other products, which are carbon dioxide and finally nitrogen gas, from this acyl chloride reaction in the presence of sodium azide and water through the rearrangement process called Curtius reaction. And I hope to see you all on the next video. All the same, stay smart as always and believe in yourselves.